Cool. So let's begin. Whoop. Maybe not. Yeah, wrong screen. Okie dokie. So, what's this talk all about? So, some sort of introduction for myself. My name is Tomáš Jamrich, as you already heard from Zdeněk. I work at Prusha Research Company as a DevOps engineer, I think. And this talk will be about Cilium and all the things that it is capable of, and not all of them, because it will be like too much long for a presentation. But I will cover the fields where I think where the technology really shines, and I will try to cover fields that you may need or may want in your Kubernetes setups to use. So, first of all, what is a CNI? Anyone knows? Cool. Awesome, thank you very much. And what is it for? Awesome, thank you very much. So you already know all of that. Basically you have your Kubernetes clusters, you have bunch of resources deployed in there, and you need some way for your services to communicate with each other. So that's what an CNI is for. So what are the commonly used ones? Which CNI do you use, if you already use? And which ones? Okay. And more cloud native ones? If any. Yeah. Correct, thank you very much. Yeah. Freaking labels, yeah. Okay. As you see from the screenshot that I took from the CNC landscape, there are a few of them. Besides the branded ones, I think from the small research I had, the most commonly used ones for sometimes are Calico, WeaveNet from Weaveworks, and Flannel, which is up there, little squares. So most of you, I think, if you don't know what CNI you use, you probably have Calico in there, because it's like the well-established standard for quite some time, and a lot of providers use this CNI by default in their managed Kubernetes clusters. So I'll try to cover some like basic features of the most commonly used ones, besides branded ones. Flannel was one of the first, so to say, CNI plugins. It is very approachable, it's very easy to use, very easy to set up, and was widely used back then. But it has, for today's scope, it has few pitfalls. One of them that I consider being really huge is that it has no support for network policies. The Calico one is based on IP table rules, which I'll speak about for some time, but wait for it. They implemented eBPF also, but so to say recently. And compared to Cilium, which is on the right side, the implementation is a bit different, mostly on the receive path. The Calico plugin, in contrast to Cilium, is owned by a private company, so it's not, so to say, like a community resourced as Cilium, but it's on the market for some time, quite long, so it's like battle tested and well established, so you can rely on it to work with like high performance. It's reliable, and compared to other stuff, it has really low latencies. And added to Flannel, the Calico has support for network policies, as you may already use some of them. But as it's relying on IP tables in the back, most of these network policies are like aware of the IP addresses, subnets, routes, and stuff like that, so no Kubernetes objects, so to speak. And in the end, the Cilium, which will cover all of this talk. Cilium is a CNI which is based on eBPF right away. I'll describe that feature later. The tool itself is owned or was donated to CNCF, and it's already a graduated project, so you can like rely on it for some time, because it's community resourced, and that's a peace of mind that a lot of companies here. When Cilium started as a CNI plugin, which was like 8 years almost, it was like hugely and fastly adopted by major providers. It has extensive feature set, and their development is like really fast. The community is agile, and the tool itself is developing like with great velocity. And in contrast to Calico, Cilium can work not only on layer 3 or 4, but also on layer 7. I will cover that later in more detail. The most killer feature I think Cilium offers is the identity-based security. So Cilium is aware of Kubernetes objects when you have them. So you can specify your policies and stuff like that based on your like pods and namespaces and services and stuff like that, and Cilium knows what objects are you talking about. Okay, next. So how a CNI will look like. Yeah, you can see that, and you already know that. Sure. Okay, the network overhead. I spoke about IP tables with Calico, and I briefly spoke about the eBPF, which I'll cover in more detail later. But as you can maybe see from the picture, when covering the network communication in your node, when dealing with IP tables, the network park is much longer, and there's much more overhead and much more like much work, much context shifts compared to the eBPF solution, as the technology that sits inside the kernel of the operating system itself. So when you switch from IP tables to eBPF, you have less overhead on a network side and less context switching. So the killer features of Cilium. The first and foremost, it can understand and it can filter network traffic, being it layer 7 protocols like HTTP, gRPC, but it can understand also like specific protocols like Kafka or Cassandra and stuff like that. Network policies understand the application level concept. As the technology sits in the kernel, that the technology that's behind the Cilium, it has a huge visibility into the network, basically up to the TCP packet level, and the eBPF technology that's basically behind the Cilium is right now supported by all Linux distros, pretty much all of them, I think. So you can like safely choose this technology regardless of what distro you use on your nodes. And the eBPF technology was like initially developed by some of the guys that already like worked on implementing Cilium itself. So the developers had a huge and deep understanding of eBPF when they were developing Cilium. So they had pretty much good expertise when developing this tool. So let's take a step back and I'll talk about what a Cilium really is. So first of all, it's an open source and cloud native piece of software. It provides network connectivity, it can secure it, it can observe it, and it's currently the most mature and most advanced CNI that CNCF offers that you can use without paying. How it all started. The first commit to the repository was done by the CEO, CTO, or the owner of the company Isovalent, Tomáš on December 2015. A few years it was like pretty unnoticed, the tool, but the last 3 or 4 years it's basically skyrocketed, and it was supported by the community. Today, the Cilium has been picked by all major vendors to their offerings. So now you can choose your SaaS solution for Kubernetes with this networking plugin. So you can try it out even with when managed Kubernetes. Okay, Cilium itself could be considered as a family of products or family of tools because they have multiple of them. So we are not just talking about the container network interface, but more plugins that they offer. First of all, it's Cilium. The other very interesting tool is called Hubble. The youngest member of the family is Tetragon, and all these technologies are backed up by eBPF. So the CNI itself, Cilium, it can provide you like the network connectivity, it can do like load balancing and all the stuff you basically expect from a networking plugin. It can operate on L3, L4, and on the application level. It already has like hundreds of big adapters, being it like Google, Yahoo, and New York Times and stuff like that, and using the eBPF as its core strength. The Hubble. Hubble is their like observability tool, so to say. Basically, when you have a technology that sits inside the kernel, you have visibility down to the level of a TCP packet. And with Hubble, you can observe what is happening, being it your pod communication, being it your service communication, being it like all the packets that through for your network flow. You can not just observe, but you can even troubleshoot, visualize, and you can set up your network policies accordingly. And it has GUI tool also. So that's like a screenshot of how it looks like. This south two parts are took from the GUI of the Hubble. So you can see your like pods and all these nice likely unseeable arrows which like describe the way of communication, the protocol that is used, the paths that are allowed by the endpoint and stuff like that. And this is like the result of some HTTP request, and the way you can observe the data flow with the CLI tool. Okie dokie. Tetragon, as I already told you, it's the youngest member of the family. It's just a few months they released their 1.0 version. It's quite young, but again, like a quickly developing tool. The tool is designed to act upon security significant events. You can enforce your policies when, I don't know, you have like some suspicious I/O activity or suspicious network file access, or some like suspicious system calls happen, and you can act accordingly with the Tetragon. Or even when some process is executed which should not be. And in the end, the little B that I already told about, eBPF, that's the core technology of all the tools that Cilium family offers. And you can like imagine it like, yeah, you all know web browsers and you all know JavaScript, yeah? It's basically an equivalent for the kernel. So you can imagine you can plug your small programs that are hooked on like system calls in kernel, and you can like trigger with a system event some program that is loaded into the kernel. So what it means for you, if you have like your container or application and stuff like that, you don't need to change anything, because this tool sees like very deep into the container down to the kernel of the operating system, which is running on. So you already see all the data flow packets and stuff like that right out of the box. Okay, there was just some like basic stuff, and if you want more, Cilium offers the kuproxy replacement, which is called the BP filter. So everyone not already using Cilium probably use kuproxy, which in the backend relies on IP tables, which we all know are slow in the end. When you have like a huge number of network policies, they are like evaluated like line by line, and if you have like a huge number of policies, that's basically your bottleneck. And with eBPF, you have it like in a hash map, so it's executed like really fast. Next we have mutual authentication, which you would probably expect when we are talking about the kernel level. If you want to switch on the MTLS with between your ports, it's like the 2 lines of YAML, so it's pretty doable, I think. Cilium offers load balancer, transparent encryption with IPsec or WireGuard technology, whichever you like or choose. They offer service mesh, cluster mesh. It can use like IPv4, IPv6, or even a combination of them. Some more creepy protocols like SCTP or multicast or stuff like that, which some like telephone operators or stuff like that may use. It can simultaneously handle multiple streams of data, and it supports like some advanced BGP features. Okay, why do we need like another tool? What is the reason why the Cilium like exists today? Yeah, Kubernetes is like not complicated, and we all know what's happening inside, right? Yeah, say no one ever. Yeah, sure. And Kubernetes is secure out of box. Yeah, said no one ever. Okay, what are the common challenges that we face today? First of all, how do I tell which service is communicating to like other service? How can I like enforce some rules that my service A can communicate only to service B and not to like service C or something similar? And how do I even put like security into this place? How do I observe it? Yeah, do you know what we can use for that? Yeah. And service mesh. Yeah, that's all the answer. Yeah. What's the problem here? We already have service mesh. We have Istio, Linkerd, Kuma, stuff like that. They are already on the market for some time. Where's the catch with all the service meshes? Yeah, thank you very much. Sidecars, we all love them or we all hate them. They have some space and they can eat up all our money. Yeah, problems that sidecar causes are like extra latency. You have like longer network communication, so it took some time. They can be pretty complex. Most significant con is they eat up like pretty much all of your resources you have. Because imagine that every single pod you have deployed in your cluster has its own sidecar. So it's just basically doubles your cost, like almost for no reason. There are some race conditions where regarding startup and shutdowns with these sidecar proxies, and they can cause some delays on the startup time because pod startup will wait until the proxy is ready, and and the other way around. Okay, let's dig into the network path with the sidecar. So we have application. It crawls back through the networking stuff and reach the proxy, leaves the proxy, leaves the virtual Ethernet device, and down to the host system through the whole networking stack. And when we don't use the sidecar and supplement with eBPF, we have the application communicating through socket directly with the virtual Ethernet device and to the host machine. When we are talking about the L3 and L4 is the left one, and with L7 right now, because the kernel is not aware of the layer 7 connectivity, we are stuck with the using of the Envoy proxy, like for now. Okay, there's some like controversy in the world right now regarding these all sidecars. In the image before, the Envoy proxy you noticed was used just for the layer 7 because we don't have that technology in the kernel yet that we are aware of the application layer. So you need to have a proxy there to have like some observability and stuff like that. Cilium uses its own Envoy config to configure these Envoy listeners. So you can specify your all like path rewrites and stuff like that on routing. The controversy here is that when you have like the standard layout with say like Istio, you have sidecar basically with every pod that you have, but with Cilium you have this proxy sidecar only once per node. So that's kind of different setup. It has its own like pros, but it also has some like drawbacks. So if you have like two services that are communicating to each other on the same node, why do you need to have two proxies for them? You don't. You are wasting your resources. But there are some cases you may want to like implement more security and not to have like many pods communicating through like one proxy. You are probably you have a much harder time troubleshooting your communication because you cannot isolate it that much when you have like all of your stuff communicating through one proxy. And if you have just one proxy on a node, it could become a spot, because if that proxy is down, then you have a problem. And yeah, then is the another one. When we are talking about the eBPF, we are at the kernel, and this proxy is in the user namespace. So you are like the troubleshooting is like vyšší dívčí, bych řekl. I don't know how to say it in English. Yeah, and with the proxy on the nodes, you can encounter like the noisy neighbor behaviors. Okay, let's take one step back and talk about the reasons why service mesh exists. Developers need basically everything from us. The application needs to communicate to like its other parts. That's like natural. Most of the times you have like multiple programming languages. They may not have like all the libraries, so they cannot talk to each other. So that was the initial reason why the communication was done through the proxy. So it was like that they don't have to be like the compatible languages because they are communicating through proxy. Developers wanted like canary rollouts and like circuit breaking, apply some rate limiting and stuff like all the service meshes can already do. Yeah, all of this stuff could be solved by sidecar. But again, you have sidecar for every single pod that you have in your Kubernetes cluster. Okay, so that's all nice. It can work with the proxy, but it only works until you receive the bill. So there must be a better way, yeah, you say. eBPF, as we already told about. Cilium has its own implementation of a service mesh. It covers all the observability fields, like it has its own ingress. It provides load balancing. It can rewrite paths. It load balances services and stuff like that. As I told, it is identity based, so you can use the Kubernetes identities, and you don't need to have like the rules for your IP addresses and subnet and stuff like that, which is like unmanageable. There's one great thing that's missing, and it's the MTLS on layer 7, which is currently on beta. and right now only working with a SPIFFE identity. But there are some ongoing effort, and even there's an effort to bring this MTLS authentication down into the kernel, but I think we are not there yet for some time. So what's the challenge with MTLS? And what's the way what a Cilium is doing like differently than every other provider? The thing is that Cilium separated the authentication and the encryption part. So the proxy initially was like designed to work with it only for TCP, but when you separate those authentication and encryption part, you can support protocols like UDP, SCTP, or multicast, which some companies may consider useful. Cilium already had like the strong network layer encryption using IPsec or WireGuard, whichever you choose. But what about the L7 again? How do we get the certificate injected into the kernel and authenticate? Well, we cannot just right now, only with the proxy. Okay, the reason why the Cilium is more than just a service mesh, the important thing is that it really understands the flow of the traffic you have inside the cluster. You can enforce policies, being it with Cilium or with Tetragon. You can write some like policies for your Cassandra or your Kafka traffic. So I don't know, you cannot like send some data to some topic. It understands the Kafka traffic itself. It works in kernel, which in the end means that it's fast in most cases, like blazing fast. You can explore the traffic you have inside between like your containers down to the TCP level. It's similar to the tab feature of Linkerd, but you can observe at a much lower level. And the important feature, you can combine Cilium CNI with existing service meshes. So if you use Istio or Linkerd, you can combine it. So it looks like eBPF is the jack of all trades, and you can use it for everything, and everything is gonna shine and be awesome. Well, not really. The technology itself is like great, and it has like very bright future, I think. And you can use it for XDP when you want to examine your raw packets as they like flow through your system, and then you can decide what to do with them. It's great for connection time load balancing, but where it does not really shine that well, or is just expensive, is when you have like packet by packet processing. That means that if you like decrypt and then re-encrypt the encrypted flows, so it needs to build a structure and do the lookup for the every packet, which is like CPU heavy and intensive, and then your nodes will eat you alive. Okay, some recapitulation in the end. So what's the pros and cons? Cilium, it's available out of the box with many of the providers, like GKE has its like V2 or the NTAS. AWS has also its solution, and I think the Azure also has it. It uses eBPF, which is so like very promising. It has strong engines for enforcing policies. In your cluster, it is aware of the Kubernetes identities, so you can get rid of the IP rules. And it has a great integration with Prometheus and all the Grafana stack. So have like nice visualizations from Hubble about your data flow. And it is really active and fast-paced project. And some pitfalls. Setup can be a bit finicky. I mean, yeah, you can have it out of box when you have a like managed solution. But if you already have a Kubernetes cluster and don't want to have a new one, you may be out of luck. But yeah, it is doable. But some providers don't let you change your CNI, or yeah, you can run like 2 CNIs at the same time, but it may involve some downtime or some errors and some mistakes that you will not be able to recover from. So basically do not suggest that. The Hubble UI, as you saw before, is a bit dated and it's not that fast, so to say, but the CLI tool is great. The Hubble GUI is great for like observing your data flow, and if you want like the ClickOps stuff or the networking policies, it's great when you like beginning to dig into, but then CLI and yeah, creepy word. All of that's in Grafana. And yeah, some features not there yet. The MTL is on the layer 7, as I already told you. So if you wanna dig into, yeah, read the documentation. That's the greatest advice I can give you. They have labs which are free, and they're awesome. Try them out. There are lots of them. They are like providing, I think there's called like the career paths. So if you are like developer, if you are a SecOps engineer, if you are, I don't know, security specialist, they can pick the correct labs regarding your areas of focus. And in the end, when you have all of them, you have like this nice island with all these checkboxes, which is very rewarding. It's like collecting Pokemons. Yeah, some of the labs are really like trivial, easy, and very approachable. And some of them require more work, but totally worth it. Okay, when the documentation doesn't help you, read it again, because the information is already in there. When this not work, you can reach the community on their Slack. They have like the weekly live stream on YouTube, which is called Eco. And every week they are covering some small features. So this is like really approachable and really easy to digest. Not that much information coming. And if you ask on their Slack, the community is very supportive. So I encourage you to try it out. Okay, that's about me. I already told you my name. There's some contact if you want to reach me out, or just like grab a beer with me. Okay, that's all from my side. So here are your questions.
It was nice promo for selling the Cilium. You should work for them.
Really?
But not right now.
Okay.
So, is there any question? Okay, so we can start.
So hi, so you mentioned that the Cilium is looking into the containers in some way or another. Is there any reason it wouldn't work with VM-based containerization, so kata containers or something like that?
No.
Awesome.
I have actually a comment and then a question because I need to make this clear, I suppose. I am quite skeptical, I guess we all are, if anything goes out from the container. So maybe I didn't get it right, because eBPF can access all the way down the kernel from the container. So it doesn't, like, there is no any security concern there. Is everything's okay?
Yes.
Well, it's all on the side of the container host. You're in control as the operator, so I would say there's no concern.
Yeah, thank you very much for
My
the
question,
much clearer explanation.
have you ever broken it? Long version. In the past, there was a Juniper Open Contrail, which compiled a big monolithic kernel module called vRouter, which magically made all routing, tunneling, and observability happen. I dismissed that as absolutely undebuggable because it was open source, but nobody was ever expected to read the code, probably. In here, it is a bit more modular with eBPF. You're injecting some bytecode into the kernel, into several hooked places. But anyway, as a network engineer, I want to have some routing tables, MAC learning, and so on. I can do that even with Open vSwitch. A bit rewriting, all right, I can adapt. But this is alien.
Yes.
I really want to see from anybody a lecture about how to break it and fix it again.
Yeah, I can confirm that debugging can be really challenging, so to speak. But the Hubble really helps. It's a great tool. Yeah, if you have Hubble, it's optional. Yeah. Okay, didn't know that. Okay, thanks for the info. Such a pitfall.
Another question? Just check the Slido if there is something. So Tom, I have one question.
Go
So
ahead.
what was the biggest setup you tried to use the Cilium? I mean, of course, production one.
Yeah, like this one, 0. Yeah, I set up at like my machine Kubernetes clusters, and I've basically done through all the labs they have, read all the resources, I think, but I have not used it in production or anywhere. Yeah, I use it at a AWS cloud provider, like so to try it out, but not like the production level.
Okay, I think we can make another talk in 1 year and talk it next time.
Sure.
So he will have space this year to implement it in the production. So we will see.
Yeah, and I'm looking forward to it. Yeah.
So
No, I guess I can help with the scale. I've seen companies run it at 1,000 to 4,000 node clusters easily. Yep. Other stuff started falling apart before Cilium, so.
Yeah, but not with my hands.
we have a question on Slido. Is Cilium made sure for migration from Istio service mesh? Can it do it GWT out, e.g. Cognito? Which ingress would you suggest to fill the possible gaps?
Yeah. I thought I grab it. Not sure about the support for the Cognito, WSNG, JVT tokens. Yeah. But yeah, it's a hard one. Right now, I think you cannot like easily migrate from Istio to Cilium without like breaking all of your stuff. You can like complement Istio with Cilium CNI to have like greater observability, but you cannot simply replace it right now. Also, yeah, Istio is like made to be used with its own like ingress gateway, which also like helps with the layer 7 authentication and stuff like that. So it's like a nice ecosystem that works on itself. But if you like try to break it with some other stuff, it can go terribly wrong. So yeah, I hope that answers the question.
Any other question? If not, I just wanted to mention that Cilium was, I'm not sure if you know it, but Cilium was acquired by, I think, Cisco. So, is the one, sorry?
Yeah, it's the one, it's the company.
Yeah, yeah, sure. I mean, just product, but. So I think that we will see it maybe in the coming future, a lot of changes. So, but it's one of the most famous CNCF tool these days. So maybe if you are going to KubeCon, you will see there a lot of talks about it. So if it's all, so thank you, Tomáš. And don't leave, just start the networking part, so we can speak about it if you want. So, have fun.